We're going to be looking at using differential equations to solve problems, which is what we were doing in class today. The first part of the lesson was how we got that equation thingy to start off with. So if you're given some, or if you realize you've got some differential equation, dy dx is equal to some ky, which you would have got from your question in the first place, how did we get y was equal to some initial value y times e to the xt? Well, if you start off with dy dx is equal to ky, remember from the previous lessons we had, we needed to get our y on the side with the dy. So I would go 1 over y, because I've just divided that by y and had 1 over y on that side. Dy is equal to k dx. And looking at that, if I take the integral of both sides, I will have the natural log of y is equal to kx plus c. Now, we don't want to know what the natural log of y is. We want our equation to be nice and neat, and we want it to say y equals. So what I'm going to do is take the e of both sides, and that will help me by undoing my natural log. So this side, my left side, will just be e, and on my right hand side I'll have e to the power of kx plus c. Now, from our previous knowledge of exponents, if you've got an exponential function with any values that are added together, remember, if your bases are the same, you added your exponent. So I could rewrite that as y equals e to the kx multiplied by e to the c. Now, this value over here is actually just a number. It is a value that is a whole number, not a whole number, a number that is not a variable at all, because c is some constant and e is an actual value of something. It is actual number. So e to the c is just some initial value that we have done, and we have chosen that to be my initial value that I am going to be intersecting into this equation. So that's where it's all coming from. Remembering that that is an actual whole value is the part that you are going to need to remember. Going over the problem that we did in class, you have a printing press, depreciates. So we are going to have the cost of it with respect to time is equal to negative 0.08. And it's the cost that's depreciating, which is why we have a C over there. Now that looks very much like my equation over here, so I know I can just put it into that equation. Of course, you can take the integral of both sides and you will end up in the same place. But I am going to go from having, we've got some cost, and that is equal to my initial cost. My initial cost that we had over here was $350,000, and that is going to be multiplied by e to the minus 0.08, and it's with respect to time that I'm talking about. Now, my cost that I'm looking for, that I want it to be equal to, is 200,000. So I have used that formula to give me this information. I now just need to solve for the t. Now, remember, the first step, step 1, was what is my differential equation? Our second step is finding what my general solution was and substituting. And now that I've substituted the values in, I can solve for what we asked for. And in this case, it's saying how long. So I'm looking for, solve for my unknown, in this case is t. So I'm going to have 200,000 divided by 350,000, and that gives me 0.57. I'm just going to leave the rest of it in my calculator while I do this, equals e to the minus 0.08t. Now I actually want to know what just this t is. Now to get that down, I need to take the natural log. Now I know we were talking in class today about I've just integrated, I've just changed it to that e from a log. Why are we going backwards? Well, we are now solving, and to solve, that's what we need to do. We might not have been given t as the unknown. We might have been given some other information, and then we would have done something else. So it just happens to be that it looks like we're going backwards, but in actual fact we're not. So my natural log of 0.57 is negative 0.56. Again, I'm going to actually keep that value in my calculator. I'm just going to round it as I write it here. And that will give me negative 0.08t. And I now need to divide by negative 0.08. And I get 6.995. So actually, it's going to be 7 years is equal to the time that I'm expecting. Okay, so I hope that's helpful. I will do another one with some of the other examples, but that was the lesson today pretty much. That yeah, got kind of swayed. I hope that'll make sense. Email me if that's going to be a problem. Cheers.